Given the head of a linked list, remove the end node from the end of the list and return its head. Immediately to start off this problem, what I'll do is I'll kind of just write the boilerplate code for LeetCode and just have a function. Remove end node. And what are the parameters? We're given the head of a linked list. And this list, like something like this maybe. And then to define the list node, something like this, we'll do value for int variable left x list node, and in the initializer we'll do value int 0 and next list node nil, right? Those are the default values, and then in this initializer we'll set the member, like the property, to the parameter value, the property of this node, to whatever is passed in here. So I think that should be okay. I'm gonna just revert this real quick. Confirm. Oh, you also want the remove the nth node from the end of the list. I'll probably, yeah, I missed that kind of portion of it. Fair enough, that's fair. All right, so I'm gonna just remove this, just so I don't get any syntax errors in LeetCode. What we should do is we should, immediately, like a clarifying question I have is whether or not this linked list is empty. But I also want to go through an example. Let's just create an example here. 1, 2, 3, 4. Okay. And it's a single linked list, right? Pretty sure. Remove the end node from the end of the list and return its head. So how do we remove the end? How do we go backwards? Do we have to do like a reversal? Or am I? Well, I don't think it was that tough. Why doesn't it delete? What in the world? Okay, let's just remove it like that then. So if n was equal to, does it start at 1 or 0? That's also my question. Like what are the nth node, the first node, second node? I think it starts at 1, right? So if we start at 2, we want to remove this node right here. So we want to change the pointer from here to here, right? I don't think it's a double linked list. So empty double linked list question. Add bounds. We're not this won't be sorted either. Yeah, I mean, like trying to think about how to solve this problem. Let me look at the constraints first. The number of nodes in the list is sz. Okay, so it's not empty. It can be in 1. The node values are from 0 to 100. Is that important? Are the node values important? I don't think they are. And then n is from 1 to a set. Okay, yeah, fair enough. Yeah, immediately I'm like starting from the end. It's tough, to be honest. If I had to go from the front, how would I go about solving this? If I had to go from the front here. So I know n is equal to 2, which is here. I know there's 4 elements in this thing. Let me change this up a little bit. An edge case I guess to consider is what if n's are at the, like n is the first, n is on the boundary, right? First or last node. Maybe that's an edge case, I don't know. So we have 5, n is equal to 5, and we want to delete this node right here. Okay. So that's 2. And then 5 minus 2 is 3, so 0, 1, 2, 3. And 0, 1, 0, 1, 2, 3. So if I subtract n by 2 and then go in this direction, that seems to be working. Okay. And I think that's the approach I'm going to go forward with. Now, if n, we have, okay, so when we have to delete this, right, we need to just change the pointer to here, and that's all. Okay, now if, let's just get this, get that, and say that we want to delete the first node, for example. What do we do? Well, if we point it to next, that's just nil. And I think that should be okay because this has a pointer to nil, right? So it shouldn't be a problem. Same thing here. If we're at this one right here, the first one, yeah, I think that's an edge case too. So if we're at the first one right here, well, we want to get rid of this, so we want to actually start from here. Right, so we're not pointing anything, or we're not pointing anything from back here. That doesn't make sense. Right, like there's nothing behind us to point to this new node right here. So we got to just set it to this new node. So that's an edge case too. All right, so what I'm going to do, actually before I even jump into the code, so I've gone through examples, I've kind of talked about these edge cases. Time complexity would be, you basically walk through this once, and the insertion or deletion anywhere in this linked list is O of 1 because it's just a pointer change. You're not like with the arrays, that would be O of n worst case. So that's nice. Space complexity, I don't think we're doing anything fancy. I think we're just doing it in place. What are we returning here? Return its head. Okay. Yeah, I think we're just updating this one right here in the parameter. So you gotta just be careful about that. That'd be something I'd ask, like, are we okay to mutate the parameter, or do we just need to create a linked list from scratch? I guess we're doing it in place. And then I would ask, is it okay for me to kind of begin coding the thought process that I have right now, or would you prefer that I kind of think of a different solution? Is there a certain direction you want me to go to? Is there something you want more optimal? Maybe you want me to go and start off with like a even more brute force solution. I don't know. Like guide me in the right direction. Okay, let's assume that this is the direction that I want to be guided in. So we have count over here. We have current. I do need to consider this edge case as n is equal to. How do we check the? length of the list? That's also a good question. Because we don't know the length of this list because it's the linked list, and there's no length tracker, which is, yeah, there should be like a length tracker, to be honest. That would make things a bit easier in this list. But what we can do, I mean, I just do like a length count, right? A length count, determine where we want to delete from. And then kind of consider this edge case and then go through it and delete. Yeah. Current is equal to head. We need to set this to a variable. While current does not equal to nil, we want to set current to the index. And there's going to be a bit of issue here because we want to set let node is equal to current and set current to node.next, so we don't have to use the optional like the question mark here. And then the action we want to take is we want to do length plus equals 1. That's all. Alright, and then if n is equal, or maybe the better way to do this, if n minus length, right? N minus length is equal to 0. Would that be the correct one? Like if I were to go through this entire, so let's say n is 5, or hold on, so 1, 2, 3, 4, 5. Oh, no wonder I'm mixing this up. Okay. Length of linked list. And then n is currently equal to 1, right? Here is 2, and then here's 5. So when it's equal to 5, then 5 minus 5 is equal to 0. And so this should be true. And then deal with deleting first node. Right, I think what you want to do in this case is just return head.next. And that could be nil. I don't know. But I mean, the thing is, we're guaranteed that there's the linked list is length of 1, but for some reason this is an optional, so we need the question mark there. Okay, now we've got the length, we've got this. Now we want to do something interesting here. You want to count. I didn't put a variable here. You want to count. While count is less than length. And we want a current like before. Let me do this first. It doesn't really matter. So let node. Let's see what the current. Okay. So current node.next. Count plus equals 1. Node to delete. That's what it's called. Node to delete. So after this is done, so For an example, let's say this was n was 2. Okay. So right here. So 5 minus 2, 3. We want to go actually to n minus length. Like that. So that's 3. Okay, so we're starting at count 0, so 0. First node check, 1, 2, 3. Hold on. What? I think I want the count afterwards. So node to delete, this is 0, then 1, then 2, then 3. And we want it to be equal to this. So stops at 3, right? Because this would be currently the first node, count would be 1. Second node, count would be 2. Third node, count would be 3. It would actually get here, wouldn't it? So 1, 2, 3, 4, right? So I'm just gonna add a 1. And now it should be okay. So count is 1. Well, we're on this first node, count is 1 now. We're on the second node, count is 2 now. We're on this third node, count is 3 now. We're on this node, count is 4 now. And count and it should stop here. Because 4 and 4, the count is 4. It should not go to the next one. Okay, so now we found a node to delete. All right. So we want a previous tracker as well, actually. Far previous, no. And then we have previous. Previous is equal to node. Okay. And then after this, we want to do the following. Previous dot next is equal to node to delete. Or maybe, yeah, node to delete. Dot next. And I'll just do question mark there. And this is going to give you problems. Oh, no, that's fine. And that deletes it, and then we want to return the head. And that should solve it, I think. I mean, let's run through an example. Let's run through, well, the example that they give, I don't want to actually do. Let me run through this example. So we have a length of 0. We have current as head. While the node is not nil, increment the length by 1 and go to the next node. So here we're at 1, 2, 3, 4, 5. Okay. Then it's going to lose the node. So we're at length 5. Pretty sure that makes sense. Does the order matter? Not really, I think. We increment 1 and then move on to the next. 1, 2, 3, like so 1, okay? And then we do check. No, we don't do check here. We just check that the current is still, no. At this point, when we go there and node.next, then that's going to be no. So this will, the while loop will stop. And then we get here, so n minus length is equal to 0. So if 5, right, if n was 5, length of the list we know is 5, and it was at 0, then it would just, oops. Then it would just set the head next. It would just return that. We first skip the first element. Which makes sense. We just want to get rid of that and then move on. Otherwise, we do a count, we have previous, we have a node to delete, and then we'll do a count, n minus length plus 1, 4. So 1, 2, 3, 4. Well, hold on. 1, 2, 3, 4. Yeah, and then 5 minus 2. Plus 1. Yep. Fourth index. Makes sense, and then we want to make sure that this, there's no discrepancy, like this node, like it's still like a valid node. So previous node, node to delete, node.next, and count plus equals 1. So we keep on doing that. We eventually get to the node to delete, and then we do a previous, which is this one dot next is equal to this one. This one, this node is removed. Now if we're at the end, let's imagine length is 0. Well, that's not possible. N minus length. N is 1. And length is 0. That's, yeah, that won't work. Length has to be at least 1. So 1 minus 1, 0 plus 1. What if n, no, but like the number of nodes. N is dependent on the number of nodes, so you can't have like 5 minus 0 plus 1 or something like that. What was I trying to like determine? Well, isn't this gonna give me some problems actually? Shouldn't it be length minus n? Yeah, I think it should be the other way around. Length minus n. Length minus n. There we go. So let's say length minus 5 minus 1, for example. 5 minus 1 plus 1. 5 minus 1 plus 1. 5. It's length 5. So 0, 1, 2, 3, 4. Five. So this is 5. Previous node, node to delete, node.next, count plus is equal to 1. So here, count is equal to 1. Here, count is equal to 2, 3, 4, 5. So now count is 5. This is 5. We're at the end. We stop. Okay, and this is also going to be false because node to delete was just sent to nil as well. Now previous dot next, this one is equal to nil. Node delete dot. Whoa, hold on. This is going to cause a problem. This is going to cause a problem. The node to delete now is this. Yeah, that's going to cause a problem. Previous is this. Okay. Good edge case to catch. How do we avoid this? So we want to get rid of this one right here. I want to take this previous one and bring it here. Am I counting this incorrectly? So ideally you want node to next. Sorry, let me try this again. One, count here, 1, 2, 3, 4, 5. So when this is 5, is this going to be in this node right here? So just give me 1 second here. I'm just trying to process this. So node to delete will be this. Count will be 1. Count 2, the node here will be like this. Right? So why am I getting confused by this? I'm getting confused between the zero base index that arrays have and the number of nodes in this list. Now, those are two things I'm getting confused with. Okay. So first of all, let's take a look at this length again. So length, we know it's 1. When this current node.next is incremented, yeah, this should be actually 2, kind of basically, because we're basically counting the next one. Well, we haven't confirmed that it actually exists yet. I'm gonna bring this count up here just to make it. So count plus equals 1. We switch over the node to node delete to node.next. Okay. And we switch over previous to be equal to the current node. Now at 2, same thing. So 1 node to delete is this. At 2, node to delete is this is the previous. At 3, node to delete is this, and this is previous. At 4, this is node to delete now, and this is previous. At 5, this is previous, and this is node to delete. Okay. But what's happening is it's wrong. This +1 is not correct. So I count 0. I can either that or do count 1, right? So count 0 plus 1, first node. Node to delete is this is previous. Count is 2. Node to delete is this is previous. Count is 3. Node to delete is this is previous. Count is 4. Node to delete is this is previous. Okay, 4. N is 5. The way we're writing this out is not nice. I'm not gonna lie. Five minus 1, 4. Plus 1. just to make this a little bit easier for me to understand, I'm just going to do this +1, +1. Okay. And now it should be like, now when the count is at 1, the count is at 5, right? Which is the node to delete. And count is equal to n. Why don't I just do this? Is that a problem? That is a problem. That is a problem. Because n is going from the back. And then when we get to this point, previous is this is a node to delete. And I'll confirm that once more. This is count. We increment count to 2. Node to delete is this. This is previous. Now count is 3. Node to delete is this. Right? So it's basically keeping track of where node to delete is. This is previous. Count is 4. Node to delete is this. This is previous. Count is 5. Node to delete is this one. This is previous. And at 5 we stop. So previous should be equal to nil. So that should be good. I'm gonna try running this. We're at 31 minutes. Syntax here is equal to nil when using textual type. Fair enough. Should be equal to list node. Let's see. Another return. Previous.next should also be like this. What happens if previous is still nil? Well, that's never going to be true because worst case this is 1, 1, 2. This will be 1, 2. So this while loop will always run once. Worst case. So we did see this ran. Let's submit it. Beautiful. Beautiful. All right. Is there anything I would do to, we're at 32 minutes, anything I would do to review, optimize this? Is this still the time complexity as stated from the beginning? Or going through the entire list once? Yes, it is. I would clean this up. Like, I think this logic could be better. It makes sense to me, it might not make sense to someone else. It's not really scalable code, which so readability is something I'd improve on. Optimizing, I mean, unless there's another time complexity or another time complexity you want me to aim for, I think this is good. There's a time complexity. Yeah, so it looks good.